Hello and welcome to Antiderivative and Integral Notation. So this is a way that we can practice doing the idea of derivative backwards. Now, something to note about integrals is there's actually two types of integrals. When we find the derivative, just find the derivative. However, when we do the antiderivative or find the integral of something, there's two different types. There's a definite integral, where we have a start and end of where we're finding the integral for. And then there's an indefinite integral where we care about what the whole function is doing as we undo the idea of a derivative. However, when we do that, it's easy to kind of reverse the power rule. Instead of subtracting, you add, and instead of multiplying, you divide. However, if there was 2 in our original problem, and then we found the derivative of that 2 would just become a 0. So when we undo that process, we kind of need to get that 2 back. But we have no more information about what that 2 was. So we stick this thing, a little c on there for our indefinite integrals. We don't need to do that in definite integrals. Oh, Mel likes that idea. C is just some constant, but we don't know what it is. The initial condition is something that helps us figure out what that C value is. It's a value from the function before it got taken into a derivative. And we can use that to figure out, okay, what was our C value? So we've got these functions, and we would like to figure out what the antiderivative of these indefinite integrals. They are indefinite integrals because we don't have a value on that little curly thing, that integral symbol. So the first thing that we want to do is we want to rewrite this as a exponent because it's just easier to work with then. So this will be x to the 1/3. So to integrate this, we would add 1 to our exponent. So we get x to the 4/3, and then we divide by whatever that exponent now is. So it's not the old exponent, we divide by what the exponent is now. So that is going to be divided by 4/3. Now we could write this a little bit cleaner, like dividing by 4/3 is the same as multiplying by 3/4. And then that x to the 4/3, if you wanted to, you could make it a cubed root, or you could leave it at 4/3. I'm feeling fancy, so I'm going to make it a radical, but either one would be fine. Now this next one, there's a whole bunch of little stuff, and we don't want to do the integral of all those little bits and then try to do like some sort of weird quotient rule. We don't have that for integrals. So let's break this up into separate little fractions. So I'm probably going to need a little more space to rewrite this, but we're going to do the integral of x to the 4 over x to the 4 minus 3x squared over x to the 4 plus 5 over x to the 4 dx. And that integral could just be a 1 minus 3, 3, and then x squared divided by x to the 4, that's x to the negative 2, plus 5 x to the negative 4. So that's my rewrite step. Then when I integrate this thing, that 1 becomes an x, because this is an x to the 0, so we add 1 to it, so it becomes x to the 1. And then we would divide that by our new exponent, which is 1, but that's a little silly. But I'll do it anyway, just for fun. So then we get negative 3, so plus negative 3x. We add 1 to that negative 2, so now it's negative 1. And we divide by our new exponent, negative 1. Plus 5, x. We have an x to the negative 4. We add 1 to that, so it becomes negative 3. And divide by our new exponent. I don't know how many of you have been yelling at me. I caught it. I missed that part. You got to add a plus c. It's so easy to forget. But whenever we're done with those integrations, we need to add a plus c. And in fact, it even should be right here. So as soon as we do that integration, we need to do that plus c at the end. Finally, let's just clean this problem up. So this is going to be x plus 3 over x minus 5 over 3x cubed plus c. And that's our integration. Now, we don't always need to keep that c there. These are some initial conditions that are going to help us get rid of that c value and actually know what that value is. If we just have that double prime of x squared, we can't figure out c. But they told us something about what happened before they did the derivative of f prime to get f double prime. So first thing we want to do is we want to integrate. So we're going to do the integral of f double prime of x, because this is what f prime of x is. So f prime of x will just be the antiderivative of f double prime of x dx. And that's just a quick reminder that we're doing the antiderivative of this with respect to x. So that is the integral of x squared dx. And then we do our process. So that is going to be x cubed divided by our new exponent, which is 3, and then we add a c. So this is what f prime of x equals at this point. But I don't know what that c value is, but I do have a hint about what that c value is using this information right here. So they're telling us that 8 is going to be what f prime of 0 is going to be. So we can plug in a 0 for x, and then we can solve this thing for c. Well, let's see, that's 0 plus c. So 0 plus what is going to be 8? Oh boy, are you surprised? It's 8. Now, sometimes they don't give us like the actual 0 one. Those ones are really easy to plug in. Sometimes there might be a little bit of solving that you need to do in order to find your c value. This time we were lucky. So now we can rewrite what f prime of x equals. It is x cubed over 3 plus 8. Okay. Now we can figure out what the original function was. So f of x is the antiderivative of f prime of x dx. So that's x cubed, the integral of x cubed over 3 plus 8x. Oh, why did I put an x there? Not yet. Dx. All right. We do our anti-differentiation process. So we add 1 to our 3 exponent. So that is x to the 4th over 3. And then we divide by our new exponent, which is 4. So I'm just going to drop that to the bottom. Then the 8 gets an x stuck on it. Because we had an x to the 0, we added 1 to it, and that makes an x to the 1. And you divide it by 1, but that doesn't do anything. And then we get our plus c. So this is our original function. But they gave us something about it. They told us something about our original function. They told us that f of 0 was 4. Okay, so we can figure out what c is now. So f of 0 is 4, which equals 0 to the 4th over 12 plus 8 times 0 plus c. Okay, well, that's 0, and that's 0. So 0 plus c equals 4. I'm pretty sure that 4 equals c. So our original function was f of x equals x to the 4 over 12 plus 8x plus 4. And you could check that by taking the derivative of that 2 times, and you should end up back with x squared. So in this video, we talked about definite and indefinite integrals, mostly indefinite integrals. where we don't have this start and end value. That will be in another video. This video was just about indefinite integrals. This initial condition is used to help us find our c values, because otherwise when we do our antiderivative of an indefinite integral, we have to have this c value at the end. Be very careful that you remember that c value. To find that antiderivative, all you have to do is add 1 to our exponent and then divide by our new exponent. Thank you for watching. Bye-bye.